Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the fifth and very exciting lecture of computer programming for civil engineers. And we are working on Python. In today's lecture, we are going to take an example of surveying in civil engineering and we'll try to learn something in Python using this example. Today's lecture is mainly about script files. We'll know with the passage of time what are these things. We'll learn how to write them, how to save them and run a Python script that we have written in these files, how to comment things and write comments about things in the Python file, and also in bonus we'll learn how to draw charts and graphs using Matplotlib library of Python. So let us start with it. Spider, and I'll open it up by clicking the icon. So once we run Spider or similar IDE or integrated development environment like PyCharm, we get an environment like this. And if you notice here, currently an untitled.py or a Python file is open on the screen. So it is a blank file and it has nothing in it, just few comments. So what Spider has done is it has written some comments for me already. This is nothing but typing something or a text that can help you in understanding what is this script or program all about. So for example, the first line here is about the code type, but I want instead of all these things something else to be written. So for example, before I want that if any person look at my code, before that they should know that it is written by me. So I can write by saying script written by Dr. Muhammad Adil, and I go to next line by pressing enter key, and then for example I wrote it on the date of um, 8 9th June 2020, for example, and I write created on this date. So now once I've written that, this is currently understood by Python that this means something. For example, if I click on this run button, I can also press F5 to run this code. You will see some kind of error will appear here. It is saying that it does not understand what is written in this file, like a script written by the whole line is not understandable because this is not a Python code, it is just a statement I want to write there. So if you want to write a remark or a comment about anything, you can start writing it actually with a hash symbol and pressing space with that, and also a hash right here and again. So now it is just a comment. You can read it at what's written there, but Python will know it is just a comment and it doesn't mean anything. Now if I try to run it, you will see it's just running this file, but no error is appearing on the screen here. So now let's start with our exercise today related to surveying in civil engineering. And in this exercise, we are informed that a leveling survey has been conducted to find out levels of ground at different locations by using leveling instrument. So we are asked to find the elevation of 7 points on the ground using surveying. So imagine we went somewhere and we found elevation of 7 points on the ground, and all these points were 50 meters apart from each other. So 50-meter apart means that there are 1, 2, 3, 4, 5, 6, and 7 points, and all of them are 50-meter apart. This means we are talking about a distance from 0 to 300 meters. Next, we are told that if elevation of the first point above sea level was already known to be 422 meters, and the elevation of the remaining 6 points with respect to the first point are 5, 8, 3, 0, 18, and 8 meters. So all are positive, means all other points are above the first point. But maybe there could have been a negative value which could have shown that from the first point it is at lower level. So 1, 2, 3, 4, 5, 6, and the seventh point is the first point, which is actually at 422 meters. So 0 meters above 422 meters. So now what we are asked is to write a Python script to plot a graph of elevations on y-axis and the distances along the x-axis. So first of all, let us play around and create this data. So first we're going to write a Python script file, which is .py file. So I'll come to Spider here, and we already have started writing the script by writing the comment, which will not be considered as any code. It's just it will help the reader of this code that it has certain information in it about the information of this code. So let me start writing the first line of the code, which is I want to arrange an array of distances from 0 to 350 meters apart so that I have 7 points as discussed. So we know that in order to do this task and create the lists of or arrays of distance and elevations, we need numpy. So let us import numpy. So I'll write the first line is import numpy as np, for example. And then in the next line, let me create a linear space from 0 to 300 of 7 points. So let us create it using numpy as np dot lin space, and within parentheses we know we want to start from 0 and we want to go all the way up to 300 meters. So as we need 7 points which are automatically 50 meters apart, I'll write 7 here. So this will now create 7 points 50 meters apart from 0 to 300. So let us also store all this result in a variable called distance. So let me do that by writing distance and equal here. And we already have a variable explorer open here so that we can see all the variables listed here. So now if I press run or F5 on the keyboard, this will run this code, but we haven't given any option here to print it on the screen or in the console here. So let me run it, so see what happens. So it ran the code and I misspelled numpy. It should be numpy. Now I run it again and see no error appeared here, but now we have a variable called distance available in the memory, which has all numbers in the form of a float. There are 7 of them and they are the numbers as we wanted them. Excellent. Next, as we are told that these elevations from the first point, the first point is at 0 meters, and from the first point relative to the first point, other points are 5, 8, 3, 0, 18, and 8 meters above it because they're all positive. So let us create another variable called elevation, but this time let us create a list of elevations by writing 0, 5, 8, 3, 0, 18, and the last value of 8 meters. We know now that this is a list which is not an array, and we have discussed it in detail in the previous lecture. So let me go to the next line and convert it into an array and store it back into elevation. So let me first write np numpy array, and within parentheses I will write that I want which list to be converted into an array, that is elevation. And I don't want to waste this variable because after this I don't need this variable, so why not I reuse it here to store this result back in the same, rather creating and wasting another portion in the computer memory. So let's recycle this variable as elevation is equal to this array. So now a list by the name of elevation will get converted into an array of elevations and will be stored in elevation. So let me run this again. So now there were double commas here in my uh, mistake. So I just remove a double comma and I run it again. So now it's running fine. But before, and also the elevation named variable with these elevations stored in the form of an array already in it. So if I don't want to run this command, I'll write a hash behind it with a space, and now you will see it is now commented. It is just a remark here. It is not going to run this time. So let me run it again, and you will see now elevation is a list of numbers. So it has changed into list because now I'm saying elevation is equal to this. But if I want this line to run, so I just uncomment it, and let me just for the sake of an example rename it to elevation 2, and now I run it. So you will notice that now elevation 2 is an array, but elevation is just a list of the same set of numbers. Notice commas in it and no commas here. It is in the form of a matrix, while this list is not. So let me remove this 2 from here and run it again and see what happens. So now notice, now elevation is back, stored back again with array, while elevation 2, because it was created today, it is still available in the memory, but we are not using it anywhere here yet. So here in the console, whenever we run this code, it just say run file, and the name of the file is unnamed file called untitled, and it's running in the directory which is this folder. But I want it to be saved now, which is the second part of today's lecture, how to save a script. So it's simple, very simple, just like other softwares like Word, Excel, or any other software you use. Simply click on File, Save, and then you move to the folder where you want to save it. I want to store it in Spring 2020, and let me store it by the name of survey example. And if I say save to this, notice now the name of the file will appear here on the top, and this time when I will run it, it will say that this file is running from this folder, and this is the name of the file. And now you can actually copy this file, email it to someone if someone needs it, or even you can run it on other computers as well, or even online if you like. So this was a simple way of saving it, and then you can always go to File, Open, and go to that folder where you saved it, and from there you can always open it back again by clicking the file and saying open to this. But it's already open, so I cancel it. So now we already know that the elevations are 422 meters above sea level. So all these numbers should be added with 422. So in order to do so, we can move to the next line, and we can say elevation is equal to elevation plus 422. So what this line will do is it will go to the array elevation, and with every individual value it will add 422 and then store it back in the same variable. We are very clever in using less computer's memory because we are using a single variable name for all other uses where we know after that this variable will not be required. So why not let's reuse it to store the data back again. So this time let me run this whole code once again without any error. We can see that this time elevation has changed and it has been incremented with 422 each. So let's write another comment about this code, that this code is about surveying at 422 elevation above sea level, so that people seeing this code will know what this code actually do. So I just write here, this is code for plotting elevations. Let me go to the next line by pressing enter and typing, continue typing. 422 meters above sea level at 7.50 meter, should be space in the units, apart. So now again, if you notice, this is just a comment. This is not a code I have written, but I want to, again, I have to comment it so that it is not run by Python or not understood by Python as a code. So just for the demonstration purpose, if I run it, you will see we have an error which is saying, what is this all about? It is an invalid syntax. This is nothing, the first line. So one way to do that is to write a hash behind it, behind every line. So this way it is commented. Now we run it and it runs smoothly. Another way of commenting multiple lines together is using triple quotes. So if I write double quote once, twice, and thrice, and then at the end of multiple lines, I write them once again, three quotes. So you will now notice the green color is showing, and so as the gray color, that these are just comments. These are multi-line comments, these are single line comments. And now this time if you run it, this all will be considered as a text, but only this code will run smoothly without any errors. You can also write a comment in front of a code as well by starting with a hash symbol. So for example, about this line I want to write incremented by 422 meters. So if I go to the next line now and run the code, you will see this is considered as a code. So this helps the reader of this code that what this line was all about. So it is a good practice to write comments in the code so that if you or any other person with whom you are sharing this code read this code, they will know from the comments what this line or this particular section of a code is all about. So let's move to our example further. So we were asked to actually plot these elevations. On y-axis and on x-axis, we need distances. So in order to draw graphs in Python, we use another library called Matplotlib library, which is a library which is rich with many useful graphing tools. And if you want to learn about it more, you go to your Google Classroom, and in your classwork, you in the section of course information, click on cheat sheets, and down there you will find 6 different types of cheat sheets, including Matplotlib, NumPy, and basic Python as well. So with future, we'll also learn pandas and SciPy with SymPy. So these cheat sheets will help you in learning more about them. So you can click, for example, Matplotlib, and in this cheat sheet, you will see many methods stepwise have been told to follow and learn how to draw and manipulate different types of graphs using Matplotlib library. So it's a very useful single page sheet which can help you in quickly learning different steps in Matplotlib, and similarly NumPy as well as basic as well as pandas and basic Python as well. So let's go back to our topic. So in order to import Matplotlib library, we have to, before using it, we have to import it somewhere in the code, because from here we need to start using it. We can start importing it right here, but it's better to import everything before writing any other code. So let me import matplotlib library as plt, for example, but I already know from the cheat sheet or from other references that inside Matplotlib library, a specific plotting tool is pyplot. So you write dot pyplot here as well. So this time the pyplot tool of Matplotlib library will be imported, and this time it will be used in our code by the name of plt. So let us use it to create a figure. First of all, a figure of the graph is just a blank box. So let me write in the next line after creating x and y axis information. So let me write plt dot figure, and of course I'll open the pencil and close them as well. So what this code will do, this will use the pyplot tool to create a blank figure inside which we can create many graphs. But this time, because I want to use it further for drawing graphs, I will name it something as well. So let me say fig variable is equal to plot figure, a blank figure. So let me run it to show you what actually it's all about. So it is saying it's run smoothly, and it has created a figure, a blank figure of 432 by 288 size. If you click in spider on plots, you will see all the plots that are drawn right in this area. So let's move on. Currently we have a blank box of size 432 by 288 pixels. Let's move on and add some graphs in it. Now what does this figure actually means, and PLT as well? So let us understand it with the help of this demonstration. So once we say matplotlib to be imported with its pyplot, it is it becomes PLT. So we call it PLT. Actually, it's a second name for this. So what is PLT or matplotlib pyplot? It is actually a box like this. So once we create and import PLT, what does PLT become? It is just a blank box, doesn't look, we cannot see where it is. What we are doing here is we are creating a blank figure inside it, and we are naming it as FIG. So what do we mean by that is this. So again, this is invisible to us, we cannot see it, but then by this line we created a blank figure inside it. And next what we are going to do is we are going to create some subgraphs or subplots inside it. So inside this figure, for example, if we imagine two rows, which is the first number here in these tuples, so there are two rows and there are three columns, 1, 2 and 3. So there are total 6 subplots, and the first subplot is called 1, second is called 2, third is 3, fourth is 4, fifth is 5 and sixth is 6, and so on if you want to create more subplots. So within this figure we can create as many small graphs as possible. So if you want to draw a graph inside this box, so you will say in subplot 235 I want to draw a graph. If you want to draw another graph within this, you will again say that I want to use this axis to draw again another graph in 235. So how to actually do that, we are going to follow in the next step. So Because in our example we just need only one graph, which means that we have one row and one column, and within that one row and one column we need only one graph, which will be something like this. So this is one row and one column and first graph in it, the only one. So let's see how to actually achieve this subplot. So in order to do that, in the next line we'll write to create one of the axis. Of course there's only one axis or one plot in it, a single plot, and let's call it as AX, and then say what we want is in the figure, which is of course in within the PLT or Matplotlib pie plot dot, we want to add a subplot. And where we want to add it, we know we want this subplot to be in the one row one column system with and on position 1 only. So this is just 1 by 1 grid of many plots, which means only one cell in it, and in that one cell we'll have only one plot. This 1 1 1 means that. So once that is done, now what we want to plot some graph inside it. So within the AX that we have just created, a single box with axis, we want to plot something in it, and on x-axis we want distance, and on y-axis we want elevation. So now in this graph we'll have arrangement of distances and elevations accordingly. And then finally what we want the whole PLT, which is actually matplotlib library.pyplot itself. We want it to be displayed on the screen, so you want to show it. So let us now run this code and see what happens. So when I play it, it draws the graph for us. And let us quickly see what actually has happened. So first, in the memory, the plot library was stored by the name of PLT, and then NumPy's library is stored by the name of NP. We used NumPy to create 7 numbers starting from 0 to 300, of course because they were linearly spaced, so every number was spaced by 50 units. Then separately we created a list of some numbers, and because we wanted 7 against 7, so these were 7 numbers there. These were the elevations of points that we surveyed. But then we needed them in the form of an array, so we converted all the elevations from list to array. Then on this array, every element is incremented to 422, so that we are now above sea level by this number. So you can see here the first point is 422 meters above sea level, and the rest of the others are also added up and incremented by 422. So then what we said create a blank PLT figure for us, which was actually this block. Then with this blank, then in PLT we said to create a figure, which was this PLT, which was created in the first line here. Within it we created a figure, and it was something like this. In the next line we said within this figure add a subplot in one row, one column, and on the first position, and store it in position AX, in variable AX, which means this. And then we asked to plot on x-axis distance and on y-axis the elevations within this AX named subplot. And then once it has drawn it, it was not displayed on the screen, so we said show it on the whole PLT on the screen. So the whole PLT with its figure and all the subplots inside it were displayed then. So just for example, if I copy all this again and and press enter and paste it after it and call this as new name by ax1 and then in the first one I say in a system of one row and two columns in the first position draw this graph and in the same system of one row and two columns in the second position draw the other graph. It should be one here as well. So the first one is ax and within ax in this position we have drawn this plot and the same plot is drawn once again but within this position because it was stored in ax1, so this plot is position ax1. So let's run this code and see the results. So here it is. We have a one row and two column system. In the first position we have this plot. In the second position we have the same plot once again. Let me multiply the elevations with 2 here so that we can differentiate between the two as well and run the code again. So we can see in the first plot, the elevations are from 422 all the way to 440, while in the other one, they start from 485 all the way to 880. So they are actually doubled, while the distances remain the same. So in today's lecture, we have learned how to write a Python script. All this is a Python script. How to save it. So from file, save, we actually saved it in the name of .py file. And then how to run this script, you simply press F5 or run by clicking this icon in spider. And then how to comment, if you want to write a comment in a single line, we use hashtag. If you want to write in front of your code, you can again use a hashtag. But if there are many lines that you want to comment all of them together, so instead of writing hash behind every one of them, you can actually close all this in a triple double quote system. And this concludes today's lecture.